Example 4. A watermelon is dropped off a cliff and hits the ground with a speed of 112 feet per second. What is the height of the cliff? You need to use the 32 feet per square second for the acceleration due to gravity, and assume there is no wind resistance or any drag. So let's say watermelon has a constant acceleration a of t equal to -32. Then take the antiderivative and find v of t equal to -32t plus c. Use the initial value, which is the basically v at the time it's dropped, and it wasn't thrown, so the initial velocity is 0. Plugging in v of 0 equal to 0 gives you c is equal to 0 and v of t equal to -32t. Now, what is the question asking? It's asking what is the height of the cliff. How do I find the height of the cliff? I found the velocity function. What I need to do is the information that is given is the speed when the watermelon hits the ground. Velocity function is a function of t, so I can actually through that find the time that has to pass for the watermelon to hit the ground, and from there I have to find the s of t or height of t to be able to plug back in the time and then get the height. So v of t is equal to the velocity function is downward, so it's -112 equal to -32t, and so t is going to be equal to 7/2. Now take the antiderivative of v of t equal to -32 right here, -32t, and find the height of t to be -16t squared plus d. Now, this d is a constant. What I know is h at 0 minus h at 7/2 is going to be the height, because the difference between the two of them is exactly the amounts that the watermelon traveled, and that's the height. And if I subtract the two from each other, these are going to cancel out. So that's the plan of action next. H of 0 minus h of 7/2, d minus -16, 7/2 to power 2 plus d, and you end up with 16 times 7/2 to power 2, which is